Hello everyone, I'm Aylin. Just like every Thursday, we are here again this week with a new topic, which is fire detection in sleeping areas. So one of the most critical aspects of fire safety is detecting the hazard at the earliest possible stage, and in areas where people are asleep, such as hotels, dormitories, hospitals, also residences, the timely detection of smoke, heat, or other signs of fire is vital for safe evacuation. So in this webinar, we will explore why fire detection systems in sleeping areas requires a specialized design approach and examine the requirements set by relevant standards and discuss the key considerations for selecting the right detectors and also planning the system layout. So as you know, in fire detection systems, selecting the right detector is crucial. And particularly in areas where people sleep, where the time required for occupants to personally detect a fire may be prolonged, the intended use of the space and the potential type of fire and environmental conditions, all of them must all be evaluated together. So while smoke detectors are prominent for early detection, and also heat or multi-sensor detectors may be preferable in areas subject to the steam, dust, or similar factors that could trigger false alarms. Therefore, the choice of detector should not be based solely on the designation of the space, but should instead take into account risk analysis and also environmental conditions. So just as early fire detection is crucial, effectively conveying the alarm to a sleeping person is equally important. Therefore, the choice of audible, visual, or audio-visual alarm devices should be based on the specific characteristics of the area, such as sounders, beacons, and also both of them, the sounder beacon. Also, we can use base sounder beacon, bottom of the detectors, and we have the base buzzer. So sounders provides a high-level audible warning in the event of a fire alarm, and it ensures that people in corridors, common areas, and similar spaces hear the alarm and begin the evacuation. Also, we have beacons, strobes, visually signals and alarm condition using a powerful flashing light. So it is particularly useful in areas with high ambient noise or where an audible alarm might be difficult to notice, difficult to hear. And also we have sounder with beacon. It combines the audible and visual warnings into a single device, and the strobe light activates simultaneously with the sounder sound, and it is a key solution for increasing the likelihood that the alarm will be noticed in areas where people are sleeping. Then we have base-mounted sounders. So an audible warning device installed beneath the fire detector or integrated into the detector base. So it provides a local audible alarm from the detector's location. So it is practical for spaces such as hotel rooms and also dormitory rooms. Then the other one is base-mounted strobe. So it is a visual alarm device positioned beneath the detector, and it provides a visual warning by emitting a flashing light. So it is particularly important in applications where the needs of individuals with hearing impairments must be considered. And the other one, base with sounder beacon. So it is an audible and visual alarm device, as you know. So it issues warnings via both a sounder sound and a strobe light. It offers an effective alarm solution for sleeping areas such as hotels, dormitories, and hospital rooms. And the last one is based with buzzer. So it is a solution integrated into the detector base that typically provides a more localized audible warning. So it just alerts the user while the connected smoke detector detects a smoke. So it can be used specifically to ensure the alarm is heard within the room itself. Yes, let's look at the project design principles. For audible alarms, the sound level must not exceed 118 decibels at any point where people might be present. And also the sound used for the fire alarm must be the same in all parts of the building. And the fire alarm sound must be at least 65 decibels or 10 decibels above any background noise, whichever is higher, and must persist for more than 30 seconds. So these minimum levels must be achieved at any point where the alarm sound is required to be heard. In a campus or complex comprising multiple buildings, the alarm sound must be the same for all buildings. So this is important. And the other point is the fire alarm sound must persist for more than 30 seconds at a level of at least 65 decibel or 10 decibel above any background noise, whichever is higher. So yes, we talked about it. Then we have, when the aim is to wake up sleeping people, the fire alarm sound must be 75 decibels. The other point is distance and sound attenuation. So in terms of sound levels, a loss of 20 decibels occurs with standard doors and 30 decibels with fire doors. So we should choose higher sounds for these obstacles. So it should not be affect the sound level. For example, if the sounder's decibel is 65 and the sound loss is 20 decibels, we should minimum use the sound level is 85 or 95 for the fire doors. So in this scenario, the intelligent addressable fire detection system operates in an integrated manner with detection and warning devices. A carbon monoxide detector in the parking area continuously monitors carbon monoxide levels and alerts the system to hazardous conditions, while a heat detector in the kitchen helps detect fires at an early stage, and smoke detectors in the office areas and meeting room rapidly identify the onset of potential fires. So in the critical archive room, the aspirating smoke detection system, which offers higher sensitivity compared with the optical smoke detectors, is employed to enhance early warning capabilities. So data from all these devices is collected and processed at the central fire alarm panel. So upon detecting a risk, the fire alarm panel activates both standard sounders and sounders with beacons, providing audible and visual warnings at the same time to the building's occupants. And simultaneously, signals from the panel trigger a relay control module to switch the elevators to the emergency mode and direct them to a safe floor. This is an example. So the system goes beyond merely generating alarms. So it plays an active role in management and monitoring. So data from the fire alarm panel is transmitted to the GCU panel, and where the system information is aggregated. Device statuses are monitored and all events are logged, as you know. So finally, this information is relayed to user monitoring screens and also allowing authorized personnel to track the situation in real time from a central location, and also enabling rapid and accurate intervention. Yes, that's all for today. Thanks for your participation. Next week we will be meet again at 11 a.m. See you.